Hey, this is TJ with ShopBot Tools, and today we're going to look at cutting HDPE cutting boards. So what we're going to focus on a lot is taking your basic rectangular shapes and now cutting irregular shapes with the ShopBot. We're also going to look into using the fluting toolpath where we can add different grooves around our boards that vary in depth. Also, some of these different grooves that we're going to be using may use specialty bits like a bowl bit. How do we add something like that to our tool database if it doesn't already exist? So we'll be on the machine, we'll be in the CAD software, and hope you enjoyed today's training. As with any material, there's different grades of it. In this high density polyethylene, there is a food grade that you can get. So suppliers is the first question people ask. Where do I get this type of material and what else is it used for? And there's a lot of sources online that are available that will tell you all about this stuff. But what we do around here, since we cut it, a lot of it, we get it in 4 foot by 8 foot sheets. So we have a plastic supplier called Piedmont Plastics, or another one called Sabic, Sabic. Those are two local sources who wholesale. They get lots of the stuff in. They have lots of it in their location, and then they bring it over as we need it. For somebody just wanting one or two pieces, there are a dozen different websites out there right now that you can buy HDPE from. Just make sure that you're getting it from a reputable source, something that looks safe for your credit card, and make sure you're getting something that says food grade, because there are different grades of this material. This stuff is really easy to cut. It's really soft plastic. It's really nice that you can get it in all kinds of different colors. You can get it in all kinds of different thicknesses. So what we're going to look at today is taking a couple files now and cutting out a different shape than just your basic rectangle and adding a fluting toolpath. I like these different channels that can all be brought down to one lower pocket here where all the juice would come down in. If you were cutting up, say, a watermelon, everything would flow down here to this little area. So let's take a look at our first project here. Familiar with using a bowl bit? What's really nice for a bowl bit is it has the radius on the edge and it has a flat bottom. So you can see two different ones pictured here. One in the case, which is a 3/4 inch, and then this one here, which is a 1 inch. So I'm going to be using this 3/4 inch one for this example. And later on in today's training, we'll also add that to the tool database. But I wanted to show you what the bit looks like before we start cutting. So here's the bowl bit, and it's zeroed, and this is a piece of 1/2 inch yellow plastic. And the first cut that we do using the fluting toolpath is where it starts out here shallow at just 20 or 30 thousandths, and then it works itself down to a depth of where the trough is going to be at the very end. That's the collection area. So there's your first toolpath, which is just 4 different flutes. The next one is a pocket toolpath. So using a pocketing toolpath with a bowl bit, I'm able to get a flat bottom with a radius edge all the way around. And I didn't have to do a bit change. That one bit has both cuts built right into it. One thing I just want to point out, and you'll see this in the file, is I always like to ramp in a bowl bit instead of just plunging that down in. That's a big bit spinning around there, and just to plunge that down in the material, that's asking a lot. So we'll ramp that down nice and easy. Gets down to its first pass depth, cleans that out, and then ramps back down to the next. And then there is a bit change here to a 1/4 inch end mill. We use an up spiral for this plastic, and you can see that it's cut out. And seeing that I just cut 2 of these, there was no sense of using the round over bit that was earlier pictured. I'd still have to do a flip operation. So I just simply went over to, I keep on my shelf 2 different routers, one with the 1/8 inch and one with the 3/16 round over bit, and went ahead and rounded over the edges and completed those 2 boards. So let's take a look at this file and how it was set up next. So we're looking at the drawing file. This is the CAD file done in VCAR Pro by Vectric. You can see it's set up for a 24 by 18. This was cut on a desktop. The calipers actually showed the 1/2 inch HDPE measuring at 0.48. So that's what I set the material thickness up for was 0.48. Everything else pretty much stays default. My X and Y is my bottom left corner, and I did 0 to the top of my material. Since I'm going to be doing a bit change and the material is the exact same size as the machine bed, I would have no other place to 0 my Z. So I'm zeroing it to the material surface. Alright, so nothing's changed there. You can see over here that I do have my drawing. This is just, showing how I came up with the dimensions and before I put radiuses on it. And the big thing was here, you can still see the circle, was I knew that I was going to be using a 3/4 inch diameter bit. And here we're looking at the edge of it. There's the bit itself, what the bowl bit would look like. It has a flat bottom with a radius. And after we see this cut, we'll come back and show you how to add this bit to the tool database. So what happens is if you purchase a bit that doesn't exist in the tool database, how do you get it entered in? And sometimes the bit manufacturer will have specs. Sometimes you actually have to draw this. There is a vector tutorial under the tutorial browser called form tools, but I'll show it to you in this training for this bit. So this little 3/4 inch circle was drawn here just to make sure it would line up with my pocket. So you can see a few lines on here. One thing I want to point out is you can see that this U shape here that was originally a full rectangle was eventually cut. This was cut off here, and it was also cut in half. So I just want to point out too that these are two halves. Alright, and the way that would have been done was going into node editing and right clicking and hitting cut vector. So instead of it being the one shape right here, it was actually right click, cut, and I had also cut it up here as well, right click and cut. So now you can see there are two separate sides. And if for some reason your green point, which is your start point, is not at this bottom corner, say I went up here, right click, and made that my start point, the problem with having the start point down inside the trough here is it's going to be shallower down here to deeper. Because when you use the fluting toolpath over here, it starts the flute from wherever your start depth is. So again, you find your start point by going into node editing. Shortcut key on the keyboard is node. Also under the drawing tab, it's under node editing here. So I'm just making sure that my start point is at this central area. And since I drew one and copied and pasted it, that would mean that these are two. So I use the fluting toolpath, which is the second one down, second one over, and this is the fluting toolpath. Since I already have it set up, let me double click on it, and you can see that I have those 4 vectors selected. I like to give this a start depth of 20 thousandths. Instead of it being flush, it's down into the material a little bit. That way if any juice was to come to this side, there is a little bit of a start depth. And then it's working itself down to 1/4 of an inch deep. And you set this flute up however you want, whether you want it to be over the complete length, down and back up. Again, this is all personal preference. And to get into more detail, again, there are Vectric tutorials on all of their different stuff in their software. But what I'm using here is the ramp over the complete length from start to finish. And notice that the ramp goes down into this pocketed area past it. If I was to have that flush, that line flush right here with this pocket, there's a good chance there'd be a thin piece of material right there. Not very much, but thin enough that I'd have to clean it up by hand. So I'm going to run it out past there. So notice this flute depth goes to 0.25 plus the start depth. So there is the depth of this. So, and then the pocket goes down to 0.38. So this pocket actually works itself down even deeper. So I like the pocket to be deeper than the flute. And you can see that here in the 3D preview. And I'll show you exactly what it is that I'm saying. And this just leaves a little bit of a lip right here, so that whatever juice or whatever that flows down here doesn't flow back up right away unless you had a lot of it flow down in there. So that's why this pocket has a little bit more of a depth to it. But notice again, the fluting toolpath and the pocket toolpath are both using this bowl bit. And that's the form tool that we're going to add right after we watch this cut out on the ShopBot. And that form tool, you can see, is a bowl bit which has a flat bottom and a radius edge right here. Alright, we'll continue on, and all I'm going to do right here is, before I went out and cut this, I would make sure that it is exactly the way I see my tabs. I can also check in here to make sure I have my ramps, and that was the big thing I wanted to make sure you guys point out and see in the video, is that you add a ramp. Alright, especially with this big bowl bit. When you're jamming that guy down inside there, you want to add a ramp to it, and that's what you see the turquoise line is right here. These turquoise lines go back and forth, and what you can see here is there's a ramp where it's going to work itself back and forth. Instead of taking a 3/4 inch diameter bit and just jamming it down into the material, that's where we ramp it down in. The bit works itself down in there. It's easier on the bit, easier on the machine. May add just a little bit of time, but overall it's worth it because what it saves. And it's going to help keep you from ever losing position. If you jam that thing down in there too hard and you lose position, then your cut is off. So I always add a ramp whenever I can. Alright, we've looked at the preview. We made sure everything is right. Let's go out and take a look at the machine cutting this file. Okay, so we got our bowl bit in, and it's going to do the fluting toolpath first because that's the order of the cut that we had. So notice that it has the shallow cut down to the deep flute, and that deepest part of the flute is where the trough will be at the end, which is the pocket toolpath. And remember, we use a bowl bit, so we have the flat bottom and a curved edge. So it's really nice for this groove here. It's a pretty wide groove. It does have a flat bottom, but it also has that round edge. It gets rid of sharp corners down inside that groove. So look at the ramp. See how that ramped down in? Not much, didn't add maybe a second to the cut, but what it did was it prevented that ShopBot from jamming that bit down into the material hard. Some bits are not designed to even plunge like that, so that's why a ramp gets around being, it allows the bit to plunge properly into the material. So you can see the step over of this bit. It does a nice job leaving the rounded edge. There's our ramp again. Down, just does a little zigzag back and forth. And here we are finishing up our pockets, and it's doing its last step over. And remember that this pocket was a little bit deeper than the actual flutes that were coming down. And again, I'm using the bull nose bit here, so I can have a curved edge and a flat bottom. And here you can see we're using the 1/4 inch up spiral. There's a ramp. Now, it was a smooth ramp in the CAD software. I put a zigzag in the video just so you could see that a ramp is being used. And now that's going to come back around. It will clean out where the ramp was. It will zigzag back down. So ramp regardless of whatever you choose, whether it's a zigzag. I prefer the smooth one, but it just doesn't show up as well in the video. Here's the tabs. Lifts up and down. Like the 3D tabs, they don't show as much on the edge, and they're real easy to nip out. There's your tab, and then finally one more tab back here where it lifts up and down. That's the 3D tab, and I can just now take a chisel and a mallet and cut those tabs out real easily. And yes, you do, not having a vacuum hold down, I have to hold that part somehow, and I use a tab. So you do need to clean that tab up on that edge. And simply for that one, again, just so you can see this, for this example, I'm just going to use a handheld router. I'm only doing 2 cutting boards. There's no sense of setting up anything special. So I just keep 2 routers on my shelf, one with an 1/8 inch roundover, one with a 1/4 inch roundover. And that finishes up those 2 projects by just rounding the edge. So the next thing we need to do is go back into the software and look at the bits that we've been using. There are all kinds of bits like keyhole bits and dovetail bits that are like the bowl bit that are not in your standard tool database until you have purchased that bit and added them. So the one we're looking at today that we've been using is the 3/4 inch. So you can go here and get the sizes that you would need. You could also get it straight from the bit manufacturer, whatever brand that you're using. You could also just measure the bit itself. So what I'm going to do is take these specs here and now add them to the drawing software, and that's what we do to make a form tool. And a form tool is what you use to create a bit in your tool database that does not exist. So we're again doing it for the 3/4 inch bowl and tray carbide bit. Now, if you're lucky enough, you could actually get right here where it says bullbit.tool. Some bit manufacturers, or you get a tool from a friend or a coworker, you could actually just go up to your tool database and import that bit in right here with import and have that bit already designed. But for the rest of us that don't have that option, what you actually need to do, and again, I'm following the Vectric tutorial here for Form Tool underneath their tutorial browser. But what I've done is I drew the bit and I used the radius and the flat bottom and the diameter, all that stuff that came from the bit manufacturer. You can see I cut the shank off it, and then finally all you see is the profile of the right hand side of the bit. No top, you don't have the top on there, you just have from the center diameter over the actual cutting edge. And that's what the Vectric software wants for making a form tool. So make sure you have the right one selected, because if you don't, when you go in to create it, it is going to give you an error message. So I have my just right hand side of my tool, and when I go into my tool database, I get to choose where I want to put it, and I don't want to mix it up with any of my nice kits that I already have together. So I'll put it underneath my custom made. I go to new, and I just want to point out that you can see that this is selected, and when I go to form tool here, it now takes that bit, doubles over the side so you can see the full diameter. You can see that it's 3/4 inch, and I would go through here and I would rename this what I want it to be so it makes sense to myself in my tool database. And one thing I also want to point out to you guys with your ShopBots here is your tool number. Make sure that tool number is somewhere between 1 and 19. If you go higher than that, what's going to happen is the ShopBot software is going to think it's a second air drill or a second spindle. So you want to keep your tool numbers underneath 20. So that's just to point out there. Pick a tool number, one that you haven't used yet, or one that you're not going to cross paths with. So again, I would go in here and dial in my feeds and my speeds, get my percentage, my step over correct for the material. And once I get everything the way I want it, I hit apply, and there it is to add the bit. So are these correct? Not at this point. What I need to do next is go to my chip load calculator and make sure that I have the right feed and speed for this. So let's bring that up next. So now I'm looking at my ShopBot 3 software, and I don't need to be connected to a machine. I could just be in preview mode. Maybe you're sitting inside at a computer that's not hooked up. All you're looking for here is tools, and you go down here to chip load calculator. And if you haven't ever used this before, there is something here that says chip load help. And what we're trying to do is figure out the correct feed and speed to use so we don't break our bit. And it explains here what chip load is in a little bit more detail. Chip load equals, it's the feed rate, which is inches per second, the bits traveling, divided by the RPM, which is revolutions per minute of the spindle, and then how many flutes you have on your, which are the cutting edges. And it's typically 1 or 2 or 3 sometimes. And down here, you can see this is a pretty rough chip load calculator. You know, right here we're using soft plastic, so we're looking for a chip load between 0.004 and 0.012. And what I would really recommend too, this is kind of like the just general calculator, our little calculator here. If you go to like onsrud.com or amana.com, some of these bit manufacturers, they have more of the scientific calculator, where instead of just saying soft plastic, you would actually go in there to HDPE and blue, and really dial in that feed and speed for that exact material that you're going to be using. So using the numbers here, if I look at a range in between, let's see, we had 0.004 and 0.012, halfway in there is 0.008, And our spindle speed, we know from the manufacturer they recommend cutting that plastic out around 18,000 RPM. And if I hit calculate, it's saying 2.4. So I'm right in that range around 2 to 2.5 inches a second. And I would go back here and change that on my tool database, and I can, I have the feed rate in there too. One thing I'd be very careful about is pass depth. That doesn't get calculated in with that simple calculator. Big bit like that, I wouldn't recommend going much deeper than 1/8 of an inch per pass. That's what I had set up in all these videos. I had to step over on that 40%, and the feed rate and the spindle speed is how I had all of the stuff on here. I chose a tool number underneath 19, and I hit apply, and now that bit becomes on there and it stays there good. So that bit now is on here, and again, when I do select to use that bit, I always add a ramp. So when I'm jamming that big bit down in that material, I've got a ramp on that. We'll look at one more design here. Again, order of the cut is something to think about. The least amount of bit changes, and then also the bit change in the order that makes sense. So the first bit we did here for the small flutes, switched to the bowl bit, which did our little trough down here. Finally, we switched to another 1/2 inch end mill, put that on a flute as well, where it started shallow, worked itself down in deep, and then did our final cut with our O flute up spiral, super O is a 1/4 inch bit that did the cutout around there, and hand routed these and gave those a nice rounded edge. And again, this is a nice style as well for cutting, and all the juice and everything flows down here to this one end. You can go on the internet and find all kinds of different images and things. Just make sure you have public domain pictures of what it is that you're going to do. You can make these cutting boards any which shape now. It's really kind of fun to make something custom for somebody, and whatever type of project it is that they're going to do, maybe a barbecue restaurant or a cheese and wine outing. Different colors, different thicknesses. It's really let your imagination take over. The different bits that we used today were nothing more than your standard ball nose, 1/4 inch and 1/2 inch. We used the V90. All these are bits that we've already used on other projects, except for the bowl bit here, which was the 3/4 inch bowl bit, which I showed you where you can find it on our store, how to add it to the tool database, and it's a great bit for doing this kind of stuff. People use it for other things too, like chair seats, decorative mantles, different things like that. And then the sky's the limit. So hope you enjoyed today's training, and we'll see you here next time.